Hello, everyone. It's look like time has come, and welcome to AI Threat Modeling 101. And I think it's requires some time to everyone who wants to join that event. And also, please leave some comments if you are here, if you're hearing me well, if you see that video. Just in case. And I also know that it's probably some kind of delay between me and LinkedIn. So just wait a couple of seconds and prepare everything here. So, and today we are going to talk about security in AI. You know, AI is a fashion topic. Everyone talking about the different models constantly, different tools, especially on a MCP, model content protocol, or agent-to-agent protocols, new protocols, new capabilities, new ways of launching things. And another part of it, it's everything going very fast. At least for me, for example, I don't have enough time. Like as I start feeling this, like I don't have enough time to verify what I'm actually running, because usually I have a habit, like just go inside the internet, just double check what is that. But in the AI experiments, it's like as things appear too fast and new tools appear too fast. I actually using another AI for a deep research about the new AI when appear on the news. So I don't even have time to read about what new tools appear. And it's also lead us to security issues, because when we run without knowing what is it, it's a bit scary, but we have to do it. So I personally, I use like a separate virtual machine for run all the experiments and not run on my own, for example, because it's too dangerous, because many of these tools, they pull some random packages from the NPM or pipe or whatever they are from Docker Hub. So it's most of MCPs works that way at the moment. But yeah, I want like us still feel safe and still understand what's going on without worrying much, without thinking it's completely unknown stuff. There's a lot of documentation about how AI works, how this MCP works, and today we're gonna do some review of a document that OWASP post. There's a couple of them, there's many of them which we post. And this one specifically related to agent AI threats and mitigations. So I think it's already a couple of minutes, and I think we should start. And yeah, if everyone is here, please just tell us where you're from, why you are here. Just any comments are very welcome. So let's go to the document. To agentic AI and mitigations from AWSP top 10 for LLM apps and GenAI agentic security initiative. It's a document from February 14, 2025, but it's still very relevant and still very valuable. They also publish another one for multi-agent system to go even deeper. But today, for us, at least one smaller things will be good enough. So what's important to read here, if you're going to read it through, it's a quote from the popular book, Artificial Intelligence, Modern Approach, 4th edition. It's a very, very good book. If you want like to know more and more about AI, it's scientific. It's about 10,000 pages, 1,100 pages, but you don't need to read it all. You don't need to be scared of a book. Just read the summaries of every chapter. It will be not that long. It will be not longer than 200, I believe, pages, so you can do it. But it's a very, very important book, and a lot of terms, a lot of things comes from that book, which was published maybe 5 or 10 years ago. I don't remember actually. So I highly recommend to read that one. But for us, what we need to actually understand here, it's this is a common common way of how to see the agentic thing at the moment, at least. It's like this agent in the middle, the LLM itself, bunch of tools which we can call functions, tools. They have different names, and of course the memory, because without the memory, all of this agent way become like just one shots. Even inside a chat GPT, everyone knows chat GPT and chat approach. Even there, we also have a short-term memory. It's chat itself. It's still the memory. So if you keep talking with the model in the chat, it will still remember what's happened in the previous messages. So it's still memory. And long-term memory, it's also more and more important at the moment, because without long-term memory, we can't we can't continue grow the agent. And of course, the common behavior of a planning, you can see it in a deep research patterns, for example, like as when we ask LM, please first create a plan, after execute one step in a plan, one by one, mark them as a success, and just double check that you're still following the plan. Like as you see here, reflection, subcritic, and so on. So this is very, very common pattern of agent ecosystem. And for the, I think we can skip a bit. Yeah. So this is how a single agent architecture can look like with more familiar parts, because it's all new services, they're supposed to find a place inside the existing ecosystem, right? So we can't just run LLM alone without anything around, without web servers, without databases, without everything surrounding things. So, and usually we expect that these agents or autonomous systems, they are work without the human. So they're supposed to talk with existing applications, with existing software. So this is how agent architecture look like at the moment. Like as for us, important part is that we have access to many services, and usually we have like quite high permissions in that services. For example, if you want AI agent work with database directly, we must provide a read and write and even administrator rights to the database, or it's supposed to read the whole code base of a company, or it's supposed to read the whole documentation or SharePoint or some kind of data swarm storages of an organization. So we have to provide the permissions, because without the data, agent will not bring any value. So we have to do this. And same, we have to support our agent with the memory. Short-term memory is easy, long-term memory is a bit harder, and vector storage is also another popular terms. So too many popular word come here and there. But the important, like as for us today, is the threads. I will not cover the multi-agent possibility. Maybe you have to understand it like as usually the coordinating agent who just send all these plans to different agents and they talk to different tools. This picture, in my opinion, could be a bit better if we like us explain that we create another agent just to talk to a specific service, not to everything. It's why we created agent, to reduce the blast radius, we reduce the possibility of that agent. But for us, like as patterns, first is one of the agentic AI threat modeling approach. It's very important. I think there's a very nice picture somewhere. Yeah, it's the same as we saw earlier, but here we can point in every piece of that system and understand what could be wrong in that part of a system. This is basically the threat modeling. Like as we see inside the memory, let's do memory first. It's short-term or long-term memory. The threat here is a memory poisoning. And memory poisoning is basically put something else, or false data, some wrong information to AI memory, because AI agents, they just follow whatever they can get. So if we put the wrong instruction in memory, we can say like as, oh, today is a 90 year, or the currency is different, exchange rate of a currency is different rate. We can do whatever we want to just affect the results of model. And if someone in organization, for example, consume that agent, ask them a question, maybe some more important question. What is our sales? What is the profit of a company from the beginning of a year till today, for example? Some important questions about money, or how many people come today to the office, some kind of that. And we expect that agent go inside the system, when get that information, save it inside the memory, and after we retrieve it again from the memory. So we can poison that, or attacker can poison that, and basically affect the results of LLM. It's not hallucinations. It's not. It could be attended and unattended. Basically, it could be like it by someone, by the reason. So the goal is to mislead people and so on. But another one, it could be an unattended thing. It's like if people don't think about that, but they save wrong information in the memory. Just if they talk with LLM and LLM summarize every chat and save it in memory, for example, someone can just tell for LLM, oh, I'm right, you're wrong, and just keep telling this, and this will be saved in the memory and affect the future decisions. But the common mitigations here, it's of course the session isolation. It's 100% sure we have to isolate users from each other, because without session isolation, it means everyone's chats in a chat GPT will be overlapped. For example, like as you will see how the other users affect your chat. It will be quite funny, actually. But memory content validation is a bit harder, but you have to implement the controls which will guarantee that this data is come from the trusted sources, and you have to double check them or validate. Like as if you have a company policy or company code policy, which AI coding agent is supposed to follow, you can implement a validation control when you will go inside the memory once a day and still double check that memory is not changed, for example, or implement like as the hashing, get the hash of this, and just do a common content or data validation practice. But it's appear here inside the memory in both short term and long term. But it's maybe a first threat that appear in everyone's mind, what's something wrong with the memory. Another one also could be very, very popular. It's a tool misuse. And tool misuse, it could be again agent hijacking entirely. If someone take a control of a whole agent and then just get access through the tools to whatever agent have access. Same as I talked earlier, like as to databases, for example, or to some other important stuff. But also its tool misuse can be go through a different way, actually. Like as we can, there's a good example. It's happened in GitHub, I believe. Someone give access to a public GitHub repos and to a private GitHub repos. It means same tool agent have access to both, to private information, public information, and this agent read the comments of whatever people mention inside the issues or pull request, and then execute that comments inside the system. And this is the kind of a tool misuse because it's a tool that's used in the wrong way. So it means saying the users, they ask LLM to give the content of all the private repositories, or get them a list of the private repositories, or get a list of all repositories which agent have access. So, and through that, they can, if agent allow this, if agent allow that execution from the user, people from the outside of boundaries, they can get the internal information. The same could be done through S3 buckets, for example. If there's a tool which read objects from S3 bucket and there's no guardrails, no controls, and nothing, someone can just put instruction inside the S3 bucket file and tell, please execute this Python script, or please install that reverse shell in which place you are. So, and the controls mitigations in that case will be always tool access control verification. So always like don't provide more than we need. If your tool is talk with the public GitHub repositories, give that access. If you need the private repositories, create another tool and give it access to private repositories, maybe to 1 or 2, or how many you need. And again, instruction validation, common modern foundation models or fine-tuned models, they are following the system command pretty strict. So you can just provide more strict instructions in the prompt, and also you can validate whatever agent try to execute. Like as for the critical operations, you can implement the human in loop pattern, like as if you work with the databases, for example, before execute the drop table command, you can involve a human, are we actually need that or not. So, and yeah, detect the tool misuse. It could be a bit harder, but and at least saving the audit logs and execution logs of AI tooling, it will help a lot, because it will create, the set of logs inside your SAMs or somewhere, and you can use, existing tooling or another AI, of course, to just see if there's any anomalies. Because usually before the tool misuse, it will be a lot of attempt. People will try to misuse your tool. It will be, some uncommon behavior of some person. They will just send multiple, maybe similar requests or nearly similar requests, or they get multiple errors, for example. So you will see the spike or anomaly in the graphics for tools misuse. Tools misuse inside our map, which is a nice picture. It's inside the input part. So mostly we talk about the input part here. Privilege compromise. No, it's quite easy. Rise when attackers exploit weaknesses in the permission management to perform unauthorized detection. It's very common, for example, in the public cloud, when someone provides administrator access to some role and then give that role to AI tools and so on. And the common practice with temporary credentials, least privilege principles, and auditing of permissions, and using temporary weighted privilege patterns. It's also help. And for prevent, like as in case of multi-agent system, it could be agent-to-agent privilege compromised. When one agent call another agent, please execute that, and that agent just blindly trust. So you can also, for the critical agents, you can implement like as guardrails in an input and output, and just control the whole thing. So you can between the like as in front of every agent in a multi-agent system, you can use the guardrails. But the T3, it's usually inside the execution loop. So it's inside the agent itself, inside the execution, inside the chain of faults. So, and this is a common for, it's privilege compromise. It's come from the software development, from the common practices. It's not anything new related for, especially for AI. Privilege compromise threats, it exists everywhere, and it exists for a while. So temporary credentials, least privileges, and so on. Resource overload. Also, the same thing with common software. We can overload the memory, lead service to crash, use distributed deny service attacks, and so on. But for AI, it's probably a bit hitting a bit harder, because it can just we can use just context overload here. It's a bit different, so we can just provide more and more content. So you have to control and implement the cutoffs before the model becomes overloaded, because before it overload the system. And usually just monitoring, quotas, rate limiting, the common pattern which already exists inside software development. But here in the AI world, if you do a multi-agent system, you probably have to implement it between the agent itself. It means you don't need to, blindly trust another agent that it will not hammer your internal tool. You don't need to think that there's some magic boundaries around your environment, and everything inside is just safe and nice. Everything outside is, the evil things. No, it's everywhere. You can implement the zero trust zero trust methodology here as well, and don't trust every agent blindly. So just implement the even internal rate limiting, because these tools used, they can be quite intense. It means same agent try to use tool, it failed, agent read the error, it's try again, and it's try much more faster than humans. So, and it's try, not, there's a programs here, they can retry behavior, it's fine. But here in an AI pattern, AI will try in very, very different manners. It means same, if this endpoint is hitting the rate limiting, it's probably try another one and try to find which one is not under the rate limiting. So the resource overload part we have here, like as also it's count like as if you're using the public LLMs, like as Anthropic, OpenAI, Bedrock, or some kind of that. If you're not hosted yourself, it means yes, you can hit the rate limiting of this third-party system as well. It's quotas or API key rate limiting or just budget constraints. So you can easily hit that if you not implement any rate limiting controls, or at least spread things across multiple endpoints. For example, if you're running a production business critical software which using public foundation models, I could suggest you to have multiple providers already in place. Like as you have OpenAI, fine. You can have like as you have Claude, for example. Claude's a better example. So you have a Claude and you have AWS Bedrock. So you at least have two examples, or you can use an open router, or you can use another third-party backup provider. Because if it's not only a downtime of third-party system, it could be just overloaded by your own usage, and you need to have some time to figure out with third-party service provider how to increase the quota, how to increase the usage, and how to pay the bill, for example. It could be like that, and you can't handle it all, in the middle of the night. So it's just difficult. It's just another model provider will save you in that case. This one is also interesting. It's a bit more AI related, like cascading hallucination attacks. This attack exploit an AI tendency to generate contextually pleasurable but false information, which can propagate through system and decision making. Yeah, it's a kind of a personal behavior of someone. When people like to, if you're running a support agent, for example, on your website, people usually like to ask that support agent to write a Python code, for example, or write a poem, or write a haiku, or write something what it's not supposed to do. And obviously you have a guardrails in place and will prevent model to follow that strange instruction. But if people can, keep doing this, keep propagate that questions through a system, and it's comes through somehow in a next agent, and in a next agent it's more applicable to a multi-agent system, because in one agent you can still control things. But if one agent passes through the next agent, and next agent doesn't have that guardrails and just follow blindly instruction, so it may execute or may have a decision-making disruption. But here it's suggested for us to establish the output validation mechanism. It's a good thing. Like as always, implement like an output validation, at least for format, but also for what we actually sending back or sending to the next agent. And usually it's required to implement the secondary AI, or if you use a managed service, it's sometimes it exists from managed service. Secondary service who will, apply some critical thinking behavior. Are we really have to do it, for example? So, and make a loop and double check. But let's see where it's on our map. Yeah, we're still talking about the model providers. So I think this is let's just cover something with especially for AI, because most of this thing like it's resource overload and privilege compromise, there's generic. So intent breaking and goal manipulation. Okay, it's a way when again you have a support. It's the same. It's kind of similar to cascading hallucinations, but here again someone try to change the end goal of AI and manipulate the data which it gets back. Like, as for example, you have a secret phrase inside your agent or some secret information inside your database, and people try to, still getting this through prompts. For example, it's maybe prompt-based attack, but it's not that hard implement at the moment, because if you do like as planning validation and if you do planning will help. If agent will just double check with the plan which is supposed to do, and it see like if someone asks for give me all the users from the database if you have any access, and AI agent can double check, no, I'm a support agent, I supposed to review the question, review the documentation, and after double check if I have that user in my database or not, and I supposed to not provide this and that. So it can planning help in that. So if you use a planning behavior, it will help in that case. Misleading and deception behaviors. Okay, their objective train models. Now, yeah, train models. It's a good advice, but it's a bit. It's not that expensive at the moment. Not the same as in the past, but having the managed service for guardrails and for exclude harmful and disallowed action or content, it's always nice. Like, as for example, AWS offer Bedrock guardrails, which can automatically exclude all harmful content. So you don't need to worry that your support agent tell something bad about the user, and when user posted in the social media and tell, oh, this company talked bad about me. So yeah, it's definitely required to put managed service, or at least another AI which will double check the outputs, so what we actually send to the user. So yeah, but it could be it's sometimes appear inside the social media. Reputation, traceability cannot be traced, an accountant doing. Yeah, it's a decision making. It's basically we have to save all this. If you use a reaction, reflect an action, if you use a chain of thoughts, we have to implement the logs of this. So we need to implement comprehensive logic, cryptographic verification, rich metadata, and real-time monitoring to ensure accountability and traceability. But it's kind of similar to a common software development. It's also required. If you have a business critical system which work with a bank transaction, you have to log everything. So same as here. If you have a business critical AI which is make the important decisions, so you have to log whatever it says, basically. And I think it's built in inside AWS Bedrock. It's one click now at the moment. Identity spoofing, also kind of common thing. Overwhelming human loop. Yeah, okay. This is more agentic. It's like if you already use this human in a loop pattern, when we ask human to make a confirmation on some specific actions, some attackers can keep asking this humans more and overwhelm them. So it means saying we have to kind of control where exactly, like as in how often we ask the humans. And as here is suggested, is the hierarchical AI human collaboration. Yeah, so it's a good suggestion, but time to time it's a bit hard to understand. So I can suggest you, like, as first maybe identify the risky part of a system, maybe make a clear understanding where is the highest risk. For example, if your AI agent decide to allow the bank transaction, for example, maybe it's a critical part of your system, so you have to implement humans there. So just identify the highest and most critical part. But at the moment, like as how the AI growing, I don't think we are closer to let AI make a high risk decisions anyway. So maybe it will require some time to establish a trust in the agent systems. But yeah, identifying which part of the system is more risky is important here. Code attacks, I kind of mentioned that. So yes, someone can upload a script in S3 and ask inside the prompt AI to execute that. I get communication poisoning. Yes, it's cross-agent distribution workflow, Rush agent, human attacks, human manipulation. Yeah, it's kind of more common thing. But yeah, it means same. I would like to highlight the big picture one more time, because if you think about your multi or single agent system in that pattern, if you do this threat modeling, but not in a generic way, how here we suggest, but inside your system, it will uncover all of your potential risks. And after you can implement required mitigations, required mitigations of that, like how you mitigate these threats and which controls you implement to solve exactly your problems. So you can try to draw kind of similar diagram for your own or maybe your future agent related software, and then try to identify where is the most risky part for you. Like as I mentioned, if agent talk to a database, is agent able to write things in database? Maybe this is the most critical part for your system. Or if agent is responsible for the money transaction, maybe this is the critical part of the system. So you can always start from the most critical to the lowest critical, and because it's where attackers probably will try to hit you in the most critical pieces of your infrastructure and the system, because they do the same. They do exactly the same. They also try to understand, where is the way how to make the system works wrong. But another important picture here, let me try to find it. Yeah, we discovered that. I think, yeah, we can talk a bit. No, I think it's, yeah, I highly recommend, like I said, we will put this document inside below the video and so on. You can read it through, because it's contain a lot of interesting mitigation strategy and the playbooks. I highly recommend to read it through. But for us, it's more interesting to talk about examples, about the trade models. We already covered a couple of them in a previous discussion, but here it's even more. So the poisoning is very simple. So attacker poisoned the agent memory over time, causing to issue unintended behavior across sessions. So it means same. It's attacker poisoned the memory of a Copilot chat like a chat GPT, and try to exfiltrate the data every time when the user engaged with agent. It means attacker can try to let the agent send back to them, to their session, whatever people do in other sessions. But it's closer to tenant isolation problem, like I said, when you have multiple tenants in the systems, multiple users, and people go back and forth. Like it's if, for example, you log in bank application, and it will be bad if you see someone else bank accounts and also do operations on behalf of someone. So this is kind of similar, but in this agentic way. So attacker try to get the information from another users. Tools misuse, we covered that. It's, yes, prompt injections, way how to inject the scripts inside the prompt and let AI agent execute the script. It's also a dangerous part. I suggest you to not let your agent execute the code, but they could try basically, like as in the OpenAI, if I remember the GPTs, if you use the GPTs of them, and they are executing the code. So it's quite an interesting thing. And goal manipulations, yeah, there's a couple of websites where you can practice your prompt injection strategy and try to manipulate end goal of AI agent. But here, yes, people will try to manipulate. Even intent or not intent, people will do it. It will always funny. But we can understand the behavior of a user. We can split like a route by behaviors. It means if you work with intent breaking goal manipulation, if you have a support agent, let's back to that topic. Support agent, and you are airplane company, and people usually ask you like, what is my booking number? Can I buy tickets? Why are my flights delayed? Or kind of this thing. But if you know your business well already and there's nothing new, you can already predefine the templates or workflow. And then the goal of first layer of support agent will be just to redirect person to known or unknown goal. It means same if someone try to make a goal manipulation and you implement this practice with a goal or workflow routing, if it's unknown goal you meet it first time, just redirect it to a human agent then, or to another AI agent which don't have high privileges. For example, your agent is capable to actually book the flight inside your CRM systems and so on. So if a person start doing some different patterns, like if first they ask for a booking the ticket, and after they start asking to math calculations, for example, 1 + 10 or kind of this, it's not related. You can use this front model router to understand, okay, user changed the behavior and changed the pattern. Let's redirect it to unknown workflow, like it's unknown workflow, and then execute it there. So you will reduce your risk and reduce this goal manipulation because it will be not possible. And this is human manipulation, reputation, traceability. Yes. Of course, yeah, it's at the moment it's a bit hard to track like logging and for agent actions, but you have to treat them like as over API calls or human calls. You have to apply the same principles. Like as if someone tried to compromise a system and it was successful, you will all at least know like as when and where it's happened, because usually all the attackers, they would like to be silent, and they want no one notice this attack because they can continue. They can do some more attacks and go more deeper and so on. So audit logging is important because also you can implement other AIs who review these audit logs for you, basically. And it could be kind of funny. Like as one agent perform the action, another agent review that actions, and if something happened, they call the third agent, to shut down the whole system, basically. But yeah, the point here is yes, post-incident investigation, and also close that problems for make it not possible to make future attacks. And in if you work in regulated environments, if you like some SOC 2, DORA, MiCA, or whatever words is applicable to your organization, it means you must do it. Because if some incident or breach happen, authorities will ask you, or another businesses will ask you, like as how you will prevent it in the future. And if you don't have any proper audit and logging systems, so you can't do it. You have to wait maybe another attack or guess where it was. So yeah. Okay, smart house security. Oh, smart house camera security. Oh, this is interesting. Let's see what we can do with IoT and smart security cameras. Like it's attacker poisoned against memory over time, causing to misclassify unauthorized access as normal behavior. Oh yeah, this is interesting. Yeah, it's like as if you use the cameras and check the entrance of a building, or use other sensors, for example, like his door was open but not. If attacker can poison the memory of or status of current environment, like as how it looked like at the moment, if they can poison this behavior, they can poison it by overloading, for example. It also could be a way of poisoning. It's not need to actually change the memory itself. You can just overload the agent system with wrong information a lot of the time, and when agent just start to believe that it's actually true. It's why we need a long-term memory to just keep in track. If you give an example how it could happen, it's like as we have a security camera, we authorize personnel by face, for example, we recognize faces, and someone tried to poison our model just to come inside the security camera very, very often in its required time together with all employees, and actually go through together with other employees, for example. And if it's happened more and more often, and if you not implement any controls, if you save everything inside the memory, your memory just get poisoned, but that wrong data just maybe not that good example because it's need to provide many attempts, but maybe opening and closing some doors, or create some anomalies inside the sensors, especially magnetic sensors by magnetic interference, or create anomalies inside with closing door sensors by trying to open them time to time. That could be, but if you have a strong long-term memory which agent can't change, so you can't just it could be mitigated. But if you not implement that, if you only operate with a short-term memory, if you try to teach your system based on the environment to reduce amount of false positives, if you have maybe too many birds that camera catch, for example, and you think, let's just let the AI learn by itself, so it could be that way. Tools misuse, interesting. Misusing its tools, such as disabling camera or modify security logs. Oh yeah, this is could be interesting. Yeah, into cleaning instruction logs, allowing it to remain detected. Yes, if AI is responsible to write data to some third-party system, it's yes, it could be a way how to clear that logs, and it is the same as the common software developer. If you provide too much privileges to your container, it also can wipe the whole system and also wipe the logs. So it's nothing that much new here. Resource overload. This could be interesting. Excessive requests causing delays or failure in the security responses. Okay. Often rely on a pattern-based event recognition, which can exploit it remotely without requiring physical access to the sensor. Okay, this is interesting. Attacker remotely exploit vulnerability in a smart house integration API. So in secured IoT, to loop fabricated motion alerts to AI-based monitoring agent. Okay, it's mean as if my home device become weird because it's got hacked, and when another security system start treating this as a normal behavior after a while. So this one, but yeah, it could be, but yeah, I think there's prioritizations. So even attacker is not physically near the house, they can manipulate data inputs to overload agent capability, creating a security blind spot. Okay, yeah, it's a kind of interesting. Maybe trying to moving the cameras in a wrong way, or trying to moving the objects inside the house. It's create a false positive movement detections. For example, if you have automated vacuum cleaner with robot stuff at flying around the floor, so if you have that one, if you have a robot inside your home, I don't, unfortunately, but if someone take control of that device, because it could be unpatched and connected to Wi-Fi and so on, so they get control of that, and after they use that robot to create motion inside your area, and when your security cameras think it's always a normal motion, and after they just do it more and more, and at some point the robots keep going, and someone else also go inside the house, and camera not detect with extra motion because they think, it's just yet another time with robots still walking around. So, but it could be interesting because if it's come to IoT, it could be interesting, because if someone train AI agent to go inside this IoT device and explore whatever this AI device can do, as autonomous, it could be very interesting way of attacks, because usually attackers, they have to prepare themselves, and when send things inside the attack zone, weaponize and so on, just bring the tools together and then go inside, go through. But here they can send autonomous agent which can learn there. Interesting pattern. Yeah, that driven automation. Let's see that one. Automated employee expense flow. No? So let's take a look. Yeah, I think that's it, I believe. Yes, and again, I would like to recommend you the book. I think it's somewhere here. If you want to read something over multiple weekends, it's artificial intelligence, modern approach at the moment, 4th edition. So I highly recommend, and you will understand all of this AI world even better. So I think this is what I would like to show. Let me see. I don't know. Do you have any questions? Any suggestions? I don't know how many people are watching us live, but if you are watching us live, or if you are watching this recording, you can still send the questions inside the comments. You can send questions to me directly, LinkedIn, X, Twitter, or whatever. I will happy to answer them. And I think just I guess stay in touch. If no more questions or so, we wait a couple of seconds, I believe, because I'm not quite sure if you get any. But again, if you're watching this in the recording and if you still have questions about AI, security, and the cloud, please let us know. Because we in FivexL, we are building secure and predictable infrastructure and beyond. And we also work with AI companies. In the past, we helped continue dev company with their infrastructure, and I think we will help them more in the future. I hope, because it's also a very nice product. If you're a user of VS Code or any JetBrains IDEA, you can try to use continue there. So I think it looks like no questions. I guess that's it. Thanks for watching. Thanks for staying at that point if you are still watching me for the last 46 minutes. So have a good day. Bye-bye.